Okay. And then the first thing is, are there any questions from what is the from Monday? And I'm going to go over OSPF. That's what we're going to primarily do. It's far too complicated to just leave it sit there like one evening's worth. But are there any questions to begin with? Okay. So what I'll do is I'm going to go over to my slides. I'm going to share my screen and go to my slides, and I think I can do. Let's try that. Yes. Okay. So we covered everything except the bottom. We didn't cover OSPF authentication last time, but
Your screen is black, or I see it black. Maybe it's just me.
Oh, it's just black. Okay. Well, let's stop the share. Let me, I think I know what I can do here. Nope, not that. There we go. Now I'll try the share again. There we go. Thank you. That better?
Yeah.
Okay. So we're going to go through all these again this evening and talk about them in a little bit more depth, a little bit more understanding. So the first thing is, let's look at what is fast convergence. What is the definition of convergence? This is something as a term you should know. It's just one of the terms that we use in networking. Anybody want to offer that up? Okay. So convergence occurs when all of the routers have the same view of the network. In other words, they all have the current view of the network. At that point, the network is considered to have converged. And before you get convergence, that means that not all routers know where everything is. And that means that if packets are sent out there, they may not get to their destination. So you want full convergence in your network. And of course, you'd like it to occur as fast as possible. Okay. Now, does anybody remember what the timers are? I don't know if we even got to these timers. I don't think we did. Did anybody happen to recall, though, from reading or anything else, the timers for OSPF? Okay. So OSPF has two primary timers that you want to know. There's other timers involved, but there are two that you would want to specifically know. One is what's called a hello timer. So we'll find out again, or get back to OSPF forming neighbor relationships. And the way that it maintains those neighbor relationships is that it sends hello messages. So every 10 seconds, each OSPF router, and when we say OSPF router, we mean every router running OSPF, will send a hello message to its neighbors, its directly connected neighbors. And it basically is saying, I'm still here and nothing has changed. And then the routers can reset their timers, knowing that now they have another 10 seconds before they have to be concerned about receiving another hello packet. So every 10 seconds, a hello is sent. Now, if a router doesn't receive a hello packet from a neighbor for 40 seconds, then it considers that neighbor dead, and all LSAs that it received from that neighbor are no longer valid. So in 40 seconds, if the router goes down, 40 seconds later, its directly connected neighbors are all going to say, whoa, that guy's gone. Therefore, the LSAs that we used from that person to compute how the network looks are no longer valid. Therefore, we have to go ahead and recompute how the network looks with that neighbor not being there. So we consider that to be fast convergence. In today's world, we'll see that actually we would lower those timers in many situations because 40 seconds is a lot of time these days for your network to not be working. So, but in the old days, when we had distance vector routing protocols, they were much slower than 40 seconds. So OSPF coming along at 40 seconds was considered fast. All right, so that's a big aspect of OSPF. Timer, it sends hello packets every 10 seconds. And if you miss 4 hellos, you consider the neighbor dead, and then you have to recalculate the network regarding in regards to that particular neighbor. Okay. All right, so the next thing is a granular metric. What is the word metric refer to? Anybody happen to recall?
Like a scale?
The scale, yes, it's how far something is away. So it's the measurement of how far something is away. And if the metric is granular, it means that it has, you might say, increments that are smaller. So if I wanted to measure how far away Santa Cruz was, and I wanted to use light years, well, it wouldn't even be 1 light year, so I'd have to round it up. So Santa Cruz would be 1 light year away, and so would New York be 1 light year away because they're both rounded up, become 1, right? So that wouldn't tell me, that gives me very poor information. It seems that Santa Cruz and New York are the same distance away, but the problem is I'm using light years. If on the other hand, I'm using miles, I can therefore see with that more granular metric that Santa Cruz is much closer than New York. And if I'm using something even more granular than miles, for example, yards, then I can not only see that Santa Cruz is closer than New York, I can also see that Capitola is much closer to Cabrillo than is Santa Cruz. So that granular metric there would allow me to discern between these various locations and more accurately discern which one was really closest. If we have to round up with some metric that's not granular, which is what was used with many distance vector routers, then we end up not being able to discern which truly is the closest. Okay. Now, it supports VLSM. We haven't got to VLSM really in detail, so we don't really know how that works. Okay. So we have hierarchical design, which involves these multiple areas, and we have the central or the core area is the backbone. That's called area 0, or named numbered area 0. And then what we can do when we add other areas in is do route summarization at those areas. And we're going to, I have this scenario that we have, that I sent you this evening. And when we load that up, I'll be able to demonstrate that. Hopefully, be able to set that up and make it work. Okay. OSPF uses multicast. Why is that a feature? What is the benefit of multicast over broadcasts? Is it significant? Anybody really care? Well, in IP version 6, they don't have broadcasts. That's how bad broadcasts are. They don't believe in broadcasts in IP version 6. It's not a religious thing. They only have multicast and unicast. So the benefit of a multicast is that we can send to a group, and that's what a multicast address is. It is a group address. We can send to a group, which is a subset of everybody, and not bother everybody when we're trying to talk to a subset. Now, I don't know if you folks ever run across this with some of your communications, either on email or text or whatever, but if you have somebody that, is sending to a group address and you're part of that group, then you get all those messages. Well, if they're actually only wanting to communicate with a couple people within that group, you end up having to deal with those messages. Well, in a sense, within that group environment, it's like a broadcast. So you would prefer they would be able to narrow those addressing down to the people that they actually want to talk to. So multicasts are addresses that refer to groups, and therefore a device that is not in the group can ignore the multicast and not have to process it. And that can take significant overhead. We also support authentication meaning that we can verify that the router that we're forming a neighbor relationship with is a valid router and not some rogue router. If we just formed a neighbor relationship with anybody, then the problem would be that people could put in rogue routers and they could mess up our network. Okay. So let's go on here. So OSPF is what's called a link state routing protocol. And it's very simply, it's going to advertise the state of its links. And those links are its particular connections to network. So if a router has 3 interfaces, they're all running OSPF in the same area, then the router will generate an LSA, a link state advertisement, for each of those networks to which it's directly connected. Before advertising to anybody else, it first forms the neighbor relationships, maintains that in a neighbor table. And those LSAs that it generates are all kept within an area, which is a way of managing the amount of update traffic that will be moved around within an area. So that's one of the reasons that we have areas, is that we can manage the update traffic. Another reason is that we're able to have summarization at area borders. And we call the area 0 the backbone, and all other areas connect to that backbone. We should not have some non-backbone area connecting to another non-backbone area, okay? And once we configure a router with interfaces in 2 or more areas, at that point it becomes an area border router. We can then issue a summary address from the area border router that indicates all the different networks that are contained within that summary address. Okay. And I'll demonstrate that tonight when we get this thing going on the scenario. Okay. So OSPF, first thing, forms an adjacency. And there are certain criteria that must be met in order for that adjacency to form. One of those is that they must have the same hello and dead timers. So if you set the router's hello and dead timers, let's say to 5 seconds, and then 20 seconds is the dead timer, and then you go to another router and you don't change it from the defaults, those 2 routers cannot form an adjacency. You'd have to make sure if you change the timers on one, that you change the timers on all the other routers with whom you want to form this adjacency. So that's right off the bat, one of the criteria, or 2 of the criteria, is that the hello and dead timers must match. the two routers to form an adjacency must also have interfaces. The facing interfaces between them must be in the same area. So what's going to happen in order to form that adjacency is they're going to start off with sending a 224.0.0.5 packet out, sending out to a multicast address. They're going to send LSAs out. They're going to basically say, here I am, and try and discover their own neighbors. And as they discover their neighbors, they're then going to exchange advertisements. And once they each have exchanged advertisements and they both have identical LSA databases, they then will calculate the shortest route. And that's the Dijkstra algorithm, or the shortest path first algorithm. So that's how they go about doing that. They maintain the adjacencies with those hello messages every 10 seconds that we mentioned. And they only send an update, actual routing update, when changes occur. So if no changes occur, then all we have as far as traffic are the hello messages. What you end up with on a multi-access network is that you could have too many adjacencies going on if everybody was trying to make an adjacency with everybody else, and then exchange information. It would just become, unscalable, problematic. And I'm not saying if I have 3 or 4, that wouldn't be a problem, but you might have, 20 or 30 routers on a given network, and that becomes quite burdensome to try and form all those neighbor relationships and then go about exchanging information. So on a multi-access network, and let's just, for right now, think in terms of Ethernet. Ethernet is a multi-access network. What's going to happen is the first router that becomes active will become a designated router. Second becomes a backup designated router, and all others become other designated routers. When the DR, or if the DR goes down, BDR becomes DR, new BDR is elected. So then we have to know, well, how is that election held? First of all, we look at the router's interface priority. Highest is best. If they tie, and the default is 1, so unless you change it, they will tie. If they tie, then the router with the highest OSPF router ID is then elected as the new BDR. And we're going to look at how we set that OSPF priority and ID. So we set the priority on the interface. Default is 1, and the command is very simple: IP OSPF priority, and then you have a number. You can set it to 0, and that way that router will not become a DR or a BDR when an election is held. Or you can set it to some other number above 1, and then the ones that are set to 1, they will be the ones that become the DR and BDRs. The OSPF router ID, you'll want to know this for the exam. They'll test you about this in different ways. One is simply to ask you something that would come right off this page: how is the router ID set? And what you'd say is the router ID is set with the router ID command, but if it's not set that way, then you would use the highest loopback address. But if there's not a loopback address, then the highest active IP address. So it's basically an if-then progression there. Okay. So when a router is going to advertise a network to a neighbor, it's going to send an LSA type of some type. Every router generates an LSA type 1 for every one of its OSPF interfaces. So if a router has 4 OSPF interfaces, it's going to generate 4 LSA type 1s. And those LSA type 1s simply say, I have this interface connected to this network. That's all it does. Very simple thing. Now, if there is a multi-access network and a DR is elected, then the DR is going to send an LSA type 2, and the LSA type 2 just describes all of the routers connected to that particular DR on that subnet. That's all it is, LA type 2. And then we have an LA type 3, which is only sent by ABRs. And essentially, an LSA type 3 is sent to one area describing networks from the other area. Okay. And when it describes those networks, it adds in a metric. So it's pretty straightforward. The metric, of course, the measurement of how far away something is. In OSPF, when we refer to the metric, it is called the cost. So if I said the OSPF cost to get from router 1 to router 3 is whatever number, that is the OSPF metric, is cost. See here referred to as cost. And calculated 10 to the 8th, whoops. We won't do that. 10 to the 8th divided by the bandwidth. So 10 to the 8th divided by the bandwidth on the interface. So what is the bandwidth? The bandwidth on an interface is a value preset for every interface. It is not dynamic. So if I have a 100 megabit interface, and for some reason it's not sending out things at quite that speed, the bandwidth value doesn't change. And we have a serial interface. The bandwidth is a value that is set on the interface, but the actual speed of the interface is determined by a clock rate. So the clock rate and the bandwidth may not match. Often they won't by default. So what you do is you would go in, if you wanted to have this used properly, you would go into the interface and change the bandwidth value to match the actual speed of the interface. That would be for serial interfaces primarily. And the reason you do that is so that OSPF then properly calculates the cost or metric to the various networks out there. OSPF does load balance by default. Whoops, is this gonna, oh no, hopefully not do this. Oh no, it's going into that loop. This is what it was doing last time. I don't even know how. Let's go back up. Let's go down here. I just change slides. I don't know why it just does this now and then. And okay. Gets into these loops. Not the least bit entertaining either. I'm closing the slideshow. That's the only way I found to stop this. Didn't do this last week. So now, are you folks seeing ping and trace route as the share?
Yeah.
Okay. So what I'll need to do is, boy, I know what I'll do. I'll open back up module 12, and then I'll go past that slide. Let me just see here. I think we can do this. Yeah, that one's not going to start looping on us. Okay. So I'll talk about load balancing. We just don't have the slide in front of us. But load balancing is simply distributing traffic over alternate routes, and OSPF will do that up to 4 equal cost routes. And this is but you want to know precisely 4 equal cost routes by default, but you can go as high as 6 if you want. So this is fully configurable from 0 to 6, but it's always going to have to be an equal cost route. There are protocols that can load balance over unequal cost routes, but OSPF does not do that. We don't need to know what those other protocols are at this point. Okay. Now, to configure OSPF, we did this last week. We go router OSPF and a process ID. This is local to this router. It does not get conveyed to any other router or neighbor router. It does not have to match on any other router. And if you do want to have it match on all your routers, that may be a good management decision, but it doesn't affect the functionality or performance. When we go router OSPF and process ID, some number, we press enter, that puts us into the configuration mode. And at that point, we can issue network statements. Network statement starts with network. And then we put in a network number, and we have a lot of options as to how we configure the network number because we have a wildcard mask that we put with it. The wildcard mask, in a wildcard mask, binary, 0 means match exactly, 1 means ignore. So we have to then go through and determine if the wildcard mask is not all zeros, which bits to match on and which bits not to match on. We follow that with the area ID, and we're going to do this here in the lab, okay? And the next two, I'm a little bit concerned that the next 2 slides might actually cause some problems. So I'm going to just go down here to the last slide. We can do a show IP route OSPF. In other words, we're going to look at the routing table. And in the routing table, what we want to see is just the routes learned from OSPF. We can see our OSPF interfaces, neighbors, and databases. Okay. So let me just pull this up. I'm going to stop this share. And then I'm going to share my scenario. Have any of you opened up this scenario? Okay, I'm gonna have to get this.
Right
Yeah,
now.
I opened it.
Okay, and you're still in the class.
Yeah, it's quite involved, right? There are a lot of routers and
A lot of stuff, isn't it?
a lot of stuff, yeah.
Let me get over here and share this. So what I did, I don't know if I explained this maybe a little bit the first night, but we didn't have this to look at. Now you can probably appreciate more of what I'm trying to accomplish here. What I did was I built this environment that would enable us to effectively, for the most part, put in all of the things, all of the capabilities that we were learning in CCNA. And the intention of this was to build a corporate network and also have a connection to the internet. So out here, this out here, can I do that? Yeah. That out there, that's the internet. Okay, so obviously it's not the whole internet, but that works for us to test whether or not we can get to the internet. We have an internet router and we have internet web server out there to test to, okay? We have 3 branch offices, one here in Monterey, one in Sacramento, one in San Jose. Originally what I did, but I've changed it now because of the CCNA changing. Originally I had a single link coming off here that then split to links here through frame relay, but they no longer teach frame relay. So then I just changed those back to regular single direct point-to-point links. So we really have 3 here And when we're configuring these, it becomes redundant because they all three will be configured basically the same. But this gives us a little more practice. What I was trying to do is have someone or the students would have to configure a point-to-point link. And then in the OSPF environment, it's point to multi-point, and that would have them configure this environment. But now it's just 3 point-to-point links. And these are going to branch offices. We have our campus. Our campus consists of 3 buildings. Building 1 has all of this over here. That's in building 1. We have building 2, which is right there. And we have building 3, which is there. And probably, actually, if we were to look at it from a truly physical way, if we were to go to where everything is, it probably would look like this. Building 3 would have the web server, would hold the switches for the backbone, and then also would hold the router that lets you get out to the internet. So this router here is your internet access. So let's look at what we're going to do in this environment here. What we want to do is run OSPF on this router, on this router, and on this router. Now, this router looks different. That's because this is actually a multi-layer switch, and a multi-layer switch is able to do routing and switching. What we have to do, and the reason why I put this in here, is the configuration is just a little different on a multi-layer switch to make it act like a layer 3 router. So we configure this to act like a layer 3 router, and then it's doing the same thing as these other 2 are doing. So really on this campus backbone at this point, there's only the campus backbone switch, and then we have these 3 links. So it's fairly simple, really, as far as what we're trying to do. We're going to run OSPF in this environment here. What we're going to do with, actually, we're going to run OSPF on these interfaces down here as well. And the reason is only that we want to advertise these networks out this way, okay? We're not going to have other routers down here that would form neighbor relationships. And so what we want to make sure is that out this way, we put in some security so that no neighbor relationships are formed on this interface, and likewise with these interfaces here. Now, we haven't learned about VLANs yet. So at this point, we're only going to work with VLAN 10 and VLAN 30. In other words, we're going to treat this entire network down here as though it's just one network, 172.16.30, and this entire network out here is 172.16.10. And that'll be fine for our purposes later when we learn about VLANs. We'll understand what's going on in these 2 areas, and then we actually have multiple networks. Right now, though, we'll just assume that we only have one network down here. So this interface here is connected to 172.16.10.0/24. This interface here, these are both on 172.16.30.0. Okay, so let's first, actually, the first thing we want to do is get these links running so we have connectivity. Let's see here. I've got fast Ethernet 00. Wait, are they addressed? Okay, that's down that way. Okay. So I think 00 points out that way, and I'm not sure on this one. I'll have to look and see what is. It's not telling me. Okay, and this over here, 00 is down. Well, let's just see if this works here. I'm going to configure on this router. Now I have to unshare, share the screen. So now I'm in router 1, building 1. And I don't believe any, no passwords are set. Oh, Zero, no, okay, so 00 does not point out there. Let's do a show IP int brief. I need to see what interfaces actually go out which direction. So 01, it looks like that could be it. Let's just try that. I'll try each one and see, we'll figure it out. Interface FA0/1 and just do a no shut. And if it comes up, that's it. If it doesn't, then okay. I'm not seeing a change on my screen as far as the arrows that indicate the activity. So let's go here, FA0, 10, FA10. Do a no shut. There we go, it's 10. Okay, so it's 10 on that one. And let's see, what did I address that? I addressed that as 172.16.60. Okay, so I'm going to have this be, since it's building one, I'm going to have this be the .1. So I'm going to go IP address 172.16.60.1, 255.255.255.0. Okay. All right. And I'm going to stop this share and go over and do the same thing on the other router.
Jerry, do you mind to go back a little bit to the first router to see what command?
Oh, okay. Well, let me
What
try it
IP?
on.
Oh, you wanna? Okay.
Hang on. Let me see here on this one. Okay, I'm on the other one. Let me just do it real quick before I go back.
Okay.
Okay. If I can get this thing, and then I'll show you int FA0/0. Do a no shut. Yes, okay. 0/0. All right. So now I'll go ahead and go back to router one, building one, and I'll share that.
And what was the last step? You went to the campus backbone and
I went to the I went to the backbone router. Yeah, the campus backbone router. And I went to in building 3, but right now I'm in building 1, and I just configured Control Z. I just configured the interface, and what we see is FA. So it's FA10 right here. You see this? Up and up?
Yeah.
Okay. So what I did is I issued a no shut. See that up there? And then I put an IP address on it. Okay. And we see here, FA10 has this IP address and it's working. Okay.
Yeah.
Okay. Stop that share. Now I did the same basic thing here. I went into FA00. I did a no shut. It came up. Now I need to put an IP address on it. IP address 172.16.60.3, because this is building 3. That's how I'm doing these. And then my mask. Okay. Now, if that worked, I should be able to ping 172.16.60.1, because that's the other router. And let's see if that works. Okay. Super. All right. So now we've got,
That's the backbone, the router that you are right now is the backbone router?
yes. So I'm going to stop this share. I'm going to go over and just share. I'm going to share the scenario again, just so we can look at the scenario for a second. See what we're doing. So what I did is I configured this one on the 172.16.60 network, and I configured that one. Those two interfaces now are operational, but I'm not running OSPF on them, okay? They're just operational. And then over here, I'm going to have to take the interface that is pointing up that, and I'm gonna have to do something sort of special on that interface because that's a multi-layer switch. And so I want you to be aware of what you have to do. So now I'm gonna go to router 1 building 2, and I'm gonna address it 172.16.60.2 on the interface that points up there. So all of these will be on the same backbone network. Let's do that. And hang on, I'm just gonna do something real quick. Switch. 0, 3, 1, 3, and 4. Okay, I think I've got it. So stop share. And let's go. Oh, you guys aren't seeing the share though.
No, we see
There we go.
the example.
Yeah, there we go. And so now, there we go. Okay, now you see the interface. This is the multi-layer switch, switch 1 in building 2, okay? Now, there isn't a second switch. I've taken it out for this, for our purposes here. So what we have is it looks like fast Ethernet 01 is actually pointing out to the other device out there. So what I'm going to do is I'm going to configure FA01, but here's what we have to do. So config P interface FA0/1. I'm hoping I've got the right one. Of course, I would make sure. And then here's the deal. By default, all interfaces on a multi-layer switch are acting at layer 2. They're acting like switch interfaces. I want it to act like a router interface, which means act like a layer 3 interface, so I can put an IP address on it. Right now, I don't think I could put an IP address on this thing. Let me just do a do show run, just to make sure that we don't have anything. No, I don't have any IP, I haven't done that, so. All right, so I'm sitting here, what I have to do is go no switch port. This is not a layer 2 switch port, and that makes it a layer 3. What it did is it went up and then it went down. Now it's layer 3. And now I can put an IP address on it. 172.16.60.2. And I'll test this in just a second and see if it works. I'll try and ping the other 2 routers. There we go. And .3. Okay, so I'm able to ping everybody on the backbone network. What I'm going to do is stop this share and talk a little bit about what we're doing. I'm going to go back and share the scenario again so we can talk about this. All right, so let's just focus on, we have that interface, and that interface on one network. So we now have, remember we talked about OSPF on a multi-access network? We now have a multi-access network, Ethernet. We have 3 interfaces. We've addressed all 3 of them. We can ping to all 3 of them. And so we have 3 operational interfaces right now. So far, we're really happy, okay? we would probably high five our co-administrator and then go out for dinner. But we can't. So we're going to go ahead and now configure OSPF. And all of this is going to be in area 0. All these interfaces. In fact, I'm going to put interfaces down here in area 0 as well. Okay, so that we understand how all this works. Because right now, I think we have some things configured down here and working, but we don't have reachability yet. Okay. So let's do this. We'll go back to router 1, building 1. I will stop my share and then share my screen again. Router 1, building 1. Okay. So what I want to do on FA10 is I want to configure, let me go, I'm sorry, I got it wrong, exit. I want to configure that to run OSPF. So I have to configure OSPF, and I'm going to go, IP OSPF. And I think 25, right? Oh, no. Router OSPF. I just blanked on that. Router OSPF. Okay, so router OSPF 25. So 25 is the process ID. And I'm now in the configuration mode. And I want to pick up, actually, what I want to do is pick up all of the interfaces. Now let's look at something. Well, you can't see on my screen, but on your screen, if you're looking at the scenario, you'll see that all of the router's interfaces are in 172.16 dot something. The one I'm on was on earlier is 172.16 dot 60.1, but the others are 172.16 dot 10 or dot 20. Everything's 172.16. So here's what I'm going to do. I'm going to pick up all the interfaces, network 172.16.0.0. Okay, that's the network. None of my interfaces are actually on that network. So I'm going to go 0.0, match that, then go .255.255 for my wildcard. And all of those are going to go in area 0. I just put all the interfaces on this router in area 0 running OSPF. Okay. So far, so good. Control Z, show IP route. And I have my directly connected interfaces. We haven't talked about what's going on down here with these 110 and 20. I know those are sub interfaces, and I'll tell you how that works later. But basically just consider that I have 3 networks connected out this one interface, FA00. I have 3 sub interfaces on that. Okay, I'm running OSPF, but I don't see any OSPF routes in my environment. That's because nobody else is giving me OSPF routes from anywhere else. That's fine. So what I'm going to do now is I'm going to go to the other routers and configure them. Stop my share. Let's see if I can share the screen. Router 1, building 3. Yes, I can. Router 1, building 3. And I was in int, yeah, FA00, right? Yep. Big T, but I'm going to go router OSPF 25. And this one I'm going to use the very specific for this interface because I want to be more careful. Network 172.16.60.3, because I specifically described that interface, I have to go 0.0.0.0 and then say that that's in area 0. Now I'm going to do a Control Z.
And that's router in building 3.
Yes, router in building 3. And let's do a show IP route and see if we picked up any information. Okay, gateway of last. Well, nothing yet. I only know about the one network. There we go. Bingo, bingo, bingo. Okay.
Can I see up your window like the
Like that?
no in your window, but like the sliding bar on the right hand side, if you don't mind to slide it up to see what you did.
Oh, what I did.
Yeah.
Okay, so here's what I did. Actually, let's do this. Here's a way to do it. Do show run. And it'll show you. So I did this. I went to router OSPF 25. Then I said network 172.16.60.3 area 0. Okay.
And this was FA00 or what? And the beginning I did not see that.
Above FA00, I just simply put that IP address on it.
I see.
Okay.
Yeah.
Okay. Now I have neighbors now. I'm running OSPF. Let's do a show IP OSPF NEI neighbors. I have one neighbor, 60.1, and that is the other neighbor out there. Show IP OSPF database. And I have various OSPF LSAs there. That's my link state database. Okay. You'll get more used to that, but basically I'm having this information advertised to me. Okay. Now I'm going to come out of here. I'm going to go to the MLS, this is the multi-layer switch. Now, I'm going to run OSPF here. Let's do something here. Let's see. Well, let me do a show IP int brief. First of all, see if anything else is configured. Whoop. Okay. One has an address, and that's it. So the other ones do not have an address. And I don't have any virtual interfaces. That's interesting. Okay, so that's fine. This is actually what we want to do, part of what I'm trying to show here. But what I'm going to do is run OSPF. So I'm going to go config T, router, OSPF 25 again, just because I like 25. IP routing is not enabled. So on this multi-layer switch, that's a little gotcha. I've got to configure IP routing to make it act like a multi-layer or router at layer 3. So note that command, IP routing. Without that, you cannot configure OSPF. So then I go router, OSPF, 25. And then I'm going to go a network statement, network. 172.16, and I'm going to use that same thing I did before, .0.0.0, 0.0.255.255. Bingo. And then area 0. Okay, there we go. So now I've got another router running OSPF, and we'll do a show what we've got here. Show IP route. Okay. And I've learned from my neighbor over there about those sub interfaces. I would be advertising something down here. God, I can't show you. Okay, I'm going to stop this share for a moment. share screen. So this is a lot, right? Configuring OSPF is, well, by itself, it's not too hard, but when we add this multi-layer switch in, we've got some things going on here. We had to, on that interface, say no switch port on that interface. On the device itself, we had to say IP routing. And now what we want is, we've got a link coming in here in a VLAN 30, but we don't have an interface that is actually in VLAN 30 yet, an actual physical or virtual interface. What we're going to do is use two virtual interfaces. I'm going to create an interface VLAN 30, an interface VLAN 40, and I'm going to give them addresses. I want you to see this happen. Stop my other share. And now share. Where is it? Right there. There we go. Okay. So I'm on the multi-layer switch. On the multi-layer switch, I need to create a virtual interface. It's a software interface. It's like LO0, except that we give it a special name in this case. When we give it a special name, that causes it to be associated with the VLAN that we give it in the way of a number. So I'm going to go interface, VLAN. I want to make sure that would be VLAN 30. Enter. Okay. So I just created an interface that didn't exist before, a virtual interface. I'm going to go IP address 172.16.30.1. Enter. And I don't even think I need this, but I'm going to put it on there just in case. Okay. So what I want you to do is see this now. Okay. Now I'll configure another one. Show IP int brief. Okay. So I've got the physical interface, fast Ethernet one up there that I made a switch. I said no switch port. That made that layer 3. But what I have down here is a virtual interface. And it's down and down, even though I did a no shut. Well, I think I know why. There's going to be some problems here that we have to do. I have to create a VLAN and I have to put assign that VLAN to an interface. So I'm going to go config T and then int FA03. This is going to be a physical interface, but it's operating at layer 2. Switch port access VLAN 30. Bingo. And that did two things. It created the VLAN and it put this interface, FA03, in that VLAN. Okay. So now we're going to go int VLAN 40. And then I'm going to do an IP address. Let's get that back. IP address. And this will be 40.1. Enter. And then I am going, and that did not come up. Then I'm going to go interface FA0/4 and make this switch port access VLAN 40, and that's going to do that. So now all of this is working. Let me do a show IP int brief. Go down there. We see now I have these two virtual interfaces. These are software interfaces. And the reason that we have these is so that now the hosts that are in these VLANs can have that as their respective default gateways. If they're in VLAN 30, they have the above one. VLAN 40 has that right there. Okay, now I'm going to do a show IP route. And I see that I have all these interfaces. I have VLAN 30 and VLAN 40 directly connected. But let's look at another one now. We're going to stop the share here and let's see what happens over on another one. Because we've got router 1, building 1. We go here to router 1, EN, show IP route. And now we've learned about the 30 and the 40 from that guy right there. That's our neighbor. Okay, so I'm going to stop this share and then go back to the scenario. All right, so we did a lot there. I realized I probably lost you because of some of the things that we're introducing, but in this environment right here, what we did is I configured that interface, physical interface, as that address, 60.3, and same thing over here, physical address on the physical interface. Over here, I had to take the physical interface and tell it to operate at layer 3 and then give it an address. I'm running OSPF on each of these 3 routers. And so this router is telling the other 2 routers about these networks down here, 172.16.40 and 172.16.30. This router is telling the other 2 routers about the various subnets down here, 10 and 20. So I haven't configured any static routes yet. I'll bet from here, I can configure interfaces here, networks here and interfaces there as well. Let me just do that. I'm going to stop that share and then share this. I'm going to prove, if I need to, connectivity. So I'm on router. This is router 3, router 1 in building 3, I should say. And what I'm going to do is do a show IP route just to see that we've got all the routes. And we have all those things we've learned through OSPF. Okay. Now we can ping 172.16.30.1. That's on the multi-layer switch. That's the virtual interface on the multi-layer switch. We can ping 40.1. That's the other virtual interface on the multi-layer switch. We can ping 10.1, which is over here off of the router 1 and building 1. And we can ping 20.1. Now, if I do a show IP OSPF, here we're getting information about my OSPF configuration. I'm running the process number 25. My router ID has been set to that right there, which makes sense. It's the only active interface. And then we have a lot of other things down here. The number of areas in this router, we only have 1, and it's a normal area. Don't worry about the others. We have not set up any authentication. The shortest path first algorithm has executed 5 times because of the various things that I've been doing. And we have this other information. I'll press space bar. That takes us through there. So we have a lot of information there. I do a show IP protocols. We see we're running OSPF 25. This is more specific to OSPF. Don't worry about that. We have a router ID set there. Again, maximum path. This is for equal cost load balancing. We are routing for these networks. This is our network statement that we've had in this router. And we're getting information from these various routers right here, ourselves and the other routers as well. Okay. Any question on this so far? Let me stop this share and share the scenario. So it's a big leap. Any questions about what I've done here? And, you know, if there's some that just totally like, what the heck is a VLAN or all that, we'll get to some of that, but I'll do the best I can to give you an explanation to work for now. So, is everybody comfortable with what I've done so far?
So and so, I still didn't catch on building 3.
Building 3. Okay, building 3, I was just on that router, has one
Yeah.
interface, okay? It has one interface out here. And that
Which is 0, 0, or which one was it?
it's FA00. You see what came up on the screen? Is that showing on your screen right now? What popped up or not?
Yeah, I see it.
Okay, so FA00 has an IP address 172.16.60.3, which means it's on this campus backbone network. That's the network for the backbone. And I'm running OSPF right here in area 0, which means this whole thing is area 0. All of these interfaces here are in area 0. This is a layer 2 switch. It's not running OSPF. It's just passing packets through.
Okay.
Okay, so OSPF running there, there, and there. So we have neighbor relationships right there. We have there. Now, let's see here. Let me go back to this. Let me do a show. Yeah, I think we do. Yeah. Okay, all right. So let me share this. Stop that other share.
And what's the order that you configured? So first building 1, building 3, and building 2?
Well, buildings 1, 2, and 3, yes. The main router in buildings 1, 2, and 3.
But the order.
The what?
The order, does it matter if it's
No.
building 1?
No, it doesn't matter what order you configure them in.
Okay, thank you.
Okay. So let's look at some things. Fast Ethernet, this is on router 1 in building 3. See it up there. FA00 is up. Line protocol is up. That's fine. Okay. The address on it is that /24. We understand what that means. And that interface is in area 0. We started this whole thing under process ID 25. The router has assigned itself ID of that right there, which of course happens to be the same as that. The network type is a broadcast. That's because it's Ethernet, and Ethernet supports broadcast. So Ethernet is considered a broadcast type of network. The cost on this interface is 1. That's the cost. That's the metric. The priority for that is 1 as well. Those two have nothing to do with each other. Cost is the metric. Priority is for elections of BDRs and DRs. We are a BDR here. We're not a DR. We're a backup designated router. Why do you think that's the case? The reason is because we're the second router to come up, not the first. The first one was router 1 in building 1. There we go. In fact, it tells us right here, designated router ID is 172.16.60.1, which is router 1 in building 1. And its interface address is that right there. So the router ID and the interface address happen to match in this case. We are the BDR, that's us, and that's our interface address that faces this. Our hello timer is 10 seconds. Our dead timer is 40 seconds. Don't worry about the others. Okay. Let's see here, what else we can look at.
I have a quick question.
Okay.
I thought you said that OSPF is only for a corporate network. Is that
Right, it's not for the internet itself.
okay? So how on your diagram do I get to San Francisco and San Jose if I don't use the internet?
You will use the internet, but you won't learn about going to those places through OSPF. OSPF tells you how, about networks, but OSPF is not going to be running out on the internet, so you won't learn about those from the OSPF. So let's talk about that, because that can be a good next step here, okay?
Does BGP have anything to do with that? Or
BGP would have something to do with what's happening on the internet
oh, okay.
and how the internet is working, but we're not going to run BGP on ours. We don't have to run BGP. Let me go here, and BGP is beyond the CCNA,
Oh, okay.
but let's look at what's going on here. This is a point-to-point network. This would be like a leased line. This is not using the internet. That's not using the internet, and that's not using the internet. But to get out here, we have to use the internet. Now, out on the internet, this is where we would use BGP. We wouldn't, but the rest of the people that are running the internet, they would use BGP.
What do you mean by leased line? What do you
What?
mean statement?
What is a lease line?
Get from building 3 to San Jose.
Building 3 to San Jose. Okay, lease line. So they would have a provider, and they would say, what we want is a dedicated line from us all the way out to the San Jose branch.
So where is building 3? What city, for example?
Building 3 would be San Francisco. This is in San Jose. Okay.
So is that like a 20-mile long fiber optic?
Well, that's going to be actually, I think it's 50 miles, about 45, 50 miles between the two. Well, it won't be a particular dedicated physical line necessarily, just like you have a line to your provider, right?
Yes.
Okay, so router 1 building 3 is going to have a line to a provider. The provider is going to have a way to get across to a provider here, and the provider here is going to connect the line down to the San Jose branch. So
Isn't that the internet?
no, that's not the internet. Okay, that's not the internet. Though, well, if you got into virtual VPNs, you can actually find the possibility you can go across the internet to do this. But if you're using your provider, you have a lease line, dedicated line. So were you ever around when there are landlines? You were around, right? When there are landlines?
Well,
Right?
I just plug it in. I don't know.
You know what I mean by, a phone that's, connected to AT&T or something like that. That's a landline, right?
Oh, okay. I was thinking LAN, not
No,
okay. Yes,
landline.
yes, yes.
Okay. So when you did that, they ran a wire from the central office to you, correct?
Yes.
And no one else was on that wire. They then have circuits that go across their network. And then at the other end, like, for example, let's say you have a friend over are you in San Jose, right?
Yes.
Yeah. So let's say you have a friend in Santa Cruz, and your friend in Santa Cruz has a landline, and they have a wire that goes from their house to the central office in Santa Cruz. But there isn't only one line that goes from Santa Cruz central office to the San Jose central office. There's multiple lines and different ways they go, but you'd have to understand all of that wide area networking. Let's just say for now that there's, a bunch of lines that go across there, okay? Tons of them. Well, let's say you picked up your receiver at your house, you called your friend, and then you left the receiver off the hook, and they left the receiver off the hook, okay?
Okay.
Now, when you wanted to talk to your friend in Santa Cruz, would you have to dial them at that point? No, you would not, right? Your receiver's off the hook, their receiver's off the hook, and you have a connection between you, the two of you. So far, so good?
Yeah.
Okay. So that would be a dedicated line between the, or dedicated connection between the two of you. Always up, no dial tone. That's what we are basically indicating here between San Jose and Router 1 Building 3. There's a dedicated line between those two. It's a dedicated connection. It goes through a provider out here, but that line is always up. It's not a dial-up connection, and it's not going through the internet.
Okay.
Just like when you call your buddy in Santa Cruz, and both leave the phones off the hook, you're not going across the internet at that point. Okay.
Okay.
Yeah. Now I realize that the way the internet has evolved and the way phone communications have evolved, that this whole thing gets more complicated now as far as an analogy. But basically, that's the concept. Well, the main office said what we want is a dedicated line down to the San Jose branch. Only our traffic goes on that line. In other words, the receiver is off the hook at each end, essentially connected to the router at each end. Traffic can go at any time. There's no dial-up involved, and we're not going through the internet.
Okay.
Okay. When we get to VPNs, what we'll see is there's a way for us to use our connection to the internet to actually go to another branch with a virtual private network. But this is a real private network. This is only our traffic. Okay. All right. So if we configured this link, there's things we then have to consider for connectivity. First of all, how does a San Jose branch know to get to all these networks in here? And how do these networks here all know how to get out to the San Jose branch? Okay. So let's look at this. Let me go down to the San Jose branch and let's see the CLI. And I'm going to see how much, because it looks like serial 10 is up. I've got to stop that share and share this one. San Jose router 1. Okay. So I'm on San Jose router 1. Okay. I'm going to do a show IP int brief. All right. So I have serial 10 up and up, but it's not addressed. So I'm going to peek over here. You guys won't be able to see me doing this because I'm going to, I haven't given that an address? Okay. Okay, so what I'm going to do is I'm going to give that link a separate link address. I'm going to call it, okay. I'm just going to call that link 200.1.1.1. And I'm going to configure each end of that. And this end will be the .2 end. So let me do that. Interface S1/0 IP address 200.1.1.1 255.255.255.0. I'm sorry. I want that to be .2, not .1. I want .1 at the other end. I want the other router to always be .1. Okay, there we go. All right. So now I'm going to go look at fix the other end. Okay, so I'm going to stop this share. I'm going to share my screen at router 1 building 3. Okay, so now en show IP int brief. I'm going to see. Okay. What serial interface is up and up? 10 is up and up. 13. Let me just do a show CDP NEI. Let me just see if this tells me anything. No, we're not running the CDP out the other end. Okay. So I'm going to take a guess here and guess that this is serial 10 because that link is showing up. It's either 10 or 13, and I'm going to guess it's 10 for right now. We'll see here. Big T int S 1/0. IP address 200.1.1.1, 255.255.255.0, enter, Control Z. And then now let's do a ping. I'm going to see if I can ping across there. This works. Yeah, okay, so I got the right interface, all right? So now what I have is the connection from San Jose to the San Francisco router 1 in building 3 working. And I can ping across there. So far, so good. All right, stop this share. Now, I am going to go over to router 1, building 1, and see what's going on over there. Okay. EN, show IP route. I don't see anything about network 200. Okay, well, I won't be able to ping it then. If I try and ping it, I'll just do ping 200.1.1.1, just for example. That's not going to work. I don't know how to get there. How do I fix that? Well, one way to fix it would be to have a default route point to router 1 in building 3. Then I don't have to learn about all these networks out there in the world. Let router 1 building 3 figure out whether it goes out in the internet or whether it goes to one of the branch offices. So I could configure a default route. I'm going to do that now. Okay. And then I'm going to take this out because we don't want to fix it this way. I'll show you how we fix it, but I want to show you the concept. IP route 0.0.0.0 space 0.0.0.0. That indicates a default route. The next hop is 172.16.60.3. Enter. Bingo. Do Control Z. Do a show IP route. Did that work? Yes, it did. I have a default gateway pointing to 172.16.60.3. Does everybody understand what I just did? We did this in class, basically, but now we're doing it in a little bit more involved scenario. Any question about what I just did? Okay, so now I'm going to ping that 200.1.1.1, and it works. I don't know how to get to 200.1.1.1, but I know if I don't know how to get there, I send it to my default gateway. And does that router know? Yes, that router knows how to get there because it's directly connected to that router. But let's try something else. Remember, on the other end of that link is a .2. Can I ping that? No, I cannot. Why not? This, by the way, is something you absolutely have to understand in the world of networking. Why I can ping one interface, but not the other. Okay, so I'm going to tell you why. Okay, stop the share. I'm going to not only tell you why, I'm going to show you how to fix it. We need to go to that where'd that San Jose office go? Oh, I must have, here, I'll have to bring up the San Jose branch. Okay. Now go back here to my share. Share, where's San Jose? Okay, close that. Try to share again. San Jose router. Okay, so now I'm on the San Jose router, Control Z. We know we can ping 200.1.1.1, right? Bingo, that works. So we have connectivity across there. We do a show IP route, but we only know about that network. So we don't know about the other networks. So we don't know how to get to them. I'm going to configure a default route here. Here we go. IP route 200. I'm sorry, IP route 0.0.0.0 space 0.0.0.0.0. And the next hop is 200.1.1.1. 1.1.1.1, enter. Bingo. See, show IP route. Ah. Okay, so now I have a default route. Now let's try and do this. Ping 172.16.60.3. This is the other interface. Yes. Or 60.1. I can pick, now I have full connectivity. The problem was I didn't have a default route on each end. Now I could have put in specific routes, but I don't want to do that. The default route on this branch router is just fine. No problem there. That's how we would normally configure it. We would configure the local interface. We did that. We would configure any Ethernet interfaces and then a default route pointing back to the branch. That's it. With this default route, once the branch office and once the main office has connectivity to the internet, this environment can go out to the internet as well. Okay, so now I'm going to stop that share and we're going to go back to, see if I can get it there, writing one building 3. Okay. Well, actually, I'm going to do something real quick. we're going to take off because this was not the solution we wanted. Okay, the reason why we didn't want this solution down here of configuring a default route because it's not scalable. What we want to do is have it come to this router differently. So I'm going to do a Control A and then put a no there. I'm going to take out the default route. So now I don't have a default route on this router here. So now I have to fix that somehow, and I'll show you how I fix it. Okay, so I'm on router 1, building 3 right now. Everybody sees that. This is the router that's connected to the internet. It's connected to all the branch offices. And what I'm going to do is I'm going to go into the router OSPF 25. And now I'm going to do this. Default information. That means default route originate. Let me see if I don't know if it supports the always. It doesn't. Say default information originate, okay? So now it's going to send a default route if it has one. Now I've got to configure a default route on this one. And I'm going to configure it right now to go to null 0, only because we don't have anything other than anyway, I'm here. Don't worry about all this, but I'm going to put a default route here. 0.0.0.0, 0.0.0.0, and then I'm going to go null 0. See if this works. Okay. All right. Null 0 means bit bucket. And the reason I'm doing that is that for right now, we don't have the whole environment configured, and therefore we don't have a good place to send this stuff. Once we have the internet set up, we would then go ahead and configure all of this properly. You will eventually be able to do all this. It'll work just fine. But that's part of the challenge here, is getting it all to work together. But now I have a default route. I'm going to stop that share. I'm going to share something else over here, router 1, building 1. Okay, so I'm back to router 1, building 1. And let's see, do I have a default route? Even though I took it out, let's see if I still have one. I do. Look at that. I have a default route. Let me see if I can ping 200.1.1.2, and I can. But I didn't configure a default route on this router. Where did I get it from? I got it from 172.16.60.3, which is that router 1 in building 3. And I got it through OSPF. And it is, this E2 means it's an external type 2. just means, it's just the way OSPF treats that the way I configured it. We'll understand about external routes with OSPF, but really for CCNA purposes, that's considered advanced. You don't have to understand about external routes and what happens with external routes coming into OSPF. But for right now, what we've done is we've configured this environment to work, and it's simply a matter of going forward and addressing and continuing this configuration. I'm going to stop my share and go back to my scenario, and we're going to talk about what this really means. Okay, so here's what's going on. Let's just review. On each of these 3 routers, I configure OSPF. I issue a network statement on this router that picks up all of these interfaces that are on this router, a network statement here that picks up all these interfaces, a network statement here that only picks up that interface. So all of these 3 are running in area 0. I then tell this router, if you have a default route in your routing table, send it out. So right now, if I went to that router, it should have a default route, even though I've never configured one on it. A default route that points right back up to there. That means if I try and send a packet from here to somewhere out in this world out here, it will send it there. Now, if this router doesn't know how to get there, it won't work. But this router does know how to get down to the San Jose branch, only across this link. It doesn't know about any of the networks down here. We're going to work on that more, not tonight, but we'll work on that, because what we want to understand is how we build connectivity in this environment. And it's a combination of static routes, default routes, a routing protocol, and this routing protocol by dynamically sending out a default route. So what we're doing right now is we're trying to fully understand OSPF, and we're only working with OSPF in one area. Okay, so we haven't made this really involved. We're only working with one area in OSPF. The difference is that I've added to the complexity of the scenario, whereas I used to have just 2 routers talking to each other. That was pretty easy. But now I've got 3 routers, I've got other networks, and I've got a branch office out here that's not running OSPF. How do I get out here? And why don't I want to run OSPF out here? Well, this router here doesn't need to know about all these routes in here. All it needs to know, if I don't know how to get there, send it there. Because look what's going to happen. If I don't know how to get there, I send it there. This router is going to know how to get there, out on the internet, all inside its own main campus. This router is going to have all the knowledge. This router simply is going to say, I don't know how to get there, I send it there. That way we're not running OSPF over this link. We're not wasting any bandwidth on this link here running OSPF. We don't need to. Okay? That's the advantage of a static route. We'll have a static route here that points to this network, a static route here that points to that network, a static route here points to that network. But we won't be running OSPF over these links. Okay? I can tell you guys are really excited about this and can't wait to go on and do this kind of stuff. All right, so what we're going to do is we'll take a break. We'll take about let's see, 7:38. Let's take a break for 17 minutes. We'll come back at 7:55, and we'll go for a while, review this. This is a lot, believe me. What you'd like to be able to do before too long is fully configure. Don't worry about the internet stuff. That actually is no more difficult than this out here. But fully configure all this environment so you have full connectivity. That's by itself a lot. We haven't even got to layer 2 switches yet. That's the easier stuff in some ways, really is. Getting all this routing to work, understanding it fully is really your best challenge right now. Okay? We'll see you in a bit. So I'm gonna pause recording. Recording. Roger, I can't hear you.
Yeah.
Can you, Georgiana, can you hear Roger?
No.
Okay, I can't hear Roger. So he said a chat. I have to put no chat. No. All right. Oh. All right. So Georgiana, how are you feeling about this?
Oh, I will have to review again the video. So I try to go along with you,
Okay.
and I did part of it with you while you were doing the router one,
Mhm.
building one.
Okay.
But then I lost the track for router one
Okay.
in building 3. But I copied everything that you are saying
Okay.
except for router 3. I told her like building 3. But
Well,
if I review,
okay. So what's going to be important now, I'm gathering from our initial first day that you're not planning to take the CCNA necessarily, right? You may not take the exam. You're here just to learn.
yeah, just to learn. And the exam is going to be later on. I don't need it really for this job that I got.
Right. So if you're just here to learn, what's most important is that you understand the concept of what we're trying to accomplish. And that's going to take a while. I mean, if you're new to this, what I'm tossing out here just these last few nights is a fairly substantial topic. So I think I said, if you were an expert in OSPF, you could make that a career. So they've got books that thick on OSPF, okay? Just on OSPF. So we're not through all of that. But in other words, it's a big topic, and it's fine if it shouldn't necessarily all, snap together like that, unless, maybe you're the genius of the world and that's how everything is for you. But for the most part, people of, who are even well versed in all this, it takes time to absorb it and to understand. And actually, even when you understand it, when you go back and do it again, you understand it better. There's always still more to learn about how it behaves and etc. So anyway, but if you're comfortable so far with, or you have questions about any concepts, just let me know. Happy to try and explain them.
Not today.
Okay.
But
Now can you hear me?
I can hear you
Yeah.
better.
Okay. So can I?
Sure.
Okay, so this is what I'm understanding. Building 3 has a static line to San Jose. So to
Static
speak.
line, okay.
Because San Jose told building 3 who I am.
Okay, now, so we need to go to the terms you're using. Between building 3 and San Jose, there is a dedicated,
line. Okay.
yes.
Okay. So
That does not mean that there's connectivity for IP. IP connectivity has to be configured. But yes, they have a physical connection or a dedicated connection between the two.
all I need to know, in my opinion, is building 3 knows about San Jose. I don't care what kind of line it is, to be honest.
Right. It doesn't really matter.
Doesn't matter. Okay, so now, because if this is OSPF, building 3 told all the routers it knows that I'm the default guy.
No,
I thought
building,
that's what you did.
no. Building 3 did not tell San Jose about a default route.
Oh, no,
because
not San Jose. No, it told
the other two.
building one and actually campus backbone and
It
building
told,
two.
it told router one and it told building one and building two that if you don't know where to send it to me. I am the your default gateway.
Okay, so now from router one, it sends a packet to this IP address. It goes, well, I don't know where it is, but I have my buddy over at building 3. He may be like the guru who knows everything. So I send my packet to building 3. Building 3 checks its routing table and says, "Oh, I know where that goes to, San
Exactly.
Jose." So it sends it to San Jose.
Exactly. So
Okay.
router one is going to initiate in this case because we're starting the ping here. But if we brought it from somewhere down below, it is the same process. Router one is going to say the destination that someone wants me to reach is 200.1.1.2. Okay. And it looks in its routing table to see if it has the 200.1.1.2 information in its own routing table. Well, so let's go ahead and I'm going to share that. We're going to go through this process. So I'm on this router one in building 1, and I'm trying to go to, I'm pinging 200.1.1.2. Okay, yeah, it happens to work. So let's see how it did. Show IP route. Enter. Okay, so what we do is we look in this routing table and do we see a match? Well, we don't match on any of these, right? The destination I just pinged, 200.1.1.2, does not match in any of these routing table entries. Or let's put it this way. The first 24 bits of that do not match the first 24 bits of that. Is that correct?
Correct.
Does the first 0 bits of that match the first 0 bits of that? Yes, correct?
Because that's the
our default.
inverse mask.
No, it's not an inverse. No, don't think of it as an inverse mask. What we're saying is you're going to look at the 0 bits. If you look at no bits, then doesn't matter what, actually it doesn't matter what's here, because here it says don't look at any of the bits. If you're trying to match against this, doesn't matter because don't look at any of the bits. A /0 is compared to nothing. Right? Conceptually? Okay. So this route here always matches a destination. As long as it's an IP address, it always matches the destination. Right? So basically we found that we had no match all the way through there, but we do have a match here. Since we have a match, we have no other match, we're going to send that next to 172.60.3. So basically what you've described is correct. I don't know where to send it except that I've got this right here. So I do know where to send it. I'm going to send it to that guy there. Boom. This is exactly how your home router works, by the way. Your home router does not know about how everything is on, where everything is on the internet. It simply knows about your local network, and if anything else, sends to the provider. Okay. So that's basically what you've got going on. So now that goes to 172.16.60.3, which is building 3, the router in building 3. Now let's go over to building 3. So now we're in router 1, building 3.
So before I do this, I have another question. I may.
Sure, go ahead.
So packet tracer is always running, which is why it crashed on me, which is fine. Is there something that you hit a button and it will actually show you the pathway of a packet? Like,
there is. I've never used that feature, but it will show you that.
Like on a simulation button, maybe?
Yeah, there is, I'd have to look where that is, but there is a mode I think you can put it into that it will actually show you the packet going from one place to another.
That's easier for me to do than looking at all those numbers and trying to figure out what the hell they mean.
Well, I understand that, but in the real world, of course, this is what you have to do to troubleshoot.
Yeah.
Yeah, okay. So now the packet has arrived at this router right here. And the destination address is 200.1.1.2. So we'd say, do the first 24 bits of that match 200.1.1.2? No. So none of these are matches. Then we go do the first 24 bits of that match the first 24 bits of 200.1.1.2. And the answer is yes, right? Is that correct?
Yes.
So we have 24 bits of this entry here that match with the destination IP address. Let's go on. Do the first 0 bits of this match the first 0 bits of the destination IP address? Yes. So now we have 2 matches, correct? Everybody okay with that?
Yes.
Okay. Now, which is the longest match? The 24 bits, correct? So therefore, it's going to send it out serial 10.
That's the dedicated line.
That's the dedicated line to San Jose, correct. That's how routing on the internet works. What we've just described, in this case, we're only going, 3 routers, router 1, building 1, router 1, building 3, and then San Jose. That's all we're doing. But if we were to go from here to who knows where, south of Africa, the process would just be repeated over and over and over again until it got there. Each router would look into its routing table and find the longest match, and based upon that longest match would forward the packet to the next router along the way.
So if something were to be sent to Europe, hypothetically, how quick does it make it to the underground sea cable, which connects?
How quickly?
How many hops do you think it takes?
Well, the hops and how fast are 2 different things. Hops are how many routers it goes over.
Okay.
How fast it gets there is how fast the routers along the way are processing the packets, because these packets are being processed at an incredibly high rate or high speed, okay?
Yeah.
I mean, the throughput on these internet routers is absolutely through the roof. I mean, I couldn't even give you a number, but it's really incredibly fast, okay? Not the speed of light, but it's really fast. And of course, the packets are traveling at whatever wire speed is along the way as well. So but how many routers would it take?
Well, I would imagine if I'm sending something to overseas, it should go, this packet is to England. Do we have like a quickie pathway, like fewer hops?
Well, you do have a way, it's called trace route. So it's a utility, trace route, and that's, whoops, yeah, no, I missed it, I misspelled it, trace route. Trace route, okay, trace route to, let's go trace route to 200.1.1.2, for example, it's not gonna be one. Router 1 trace route. Let me see. Okay, I'm sorry. It's going to be different. Trace route. That's a trace route. That's the PC version. There we go. Trace route on the router is a trace route. It's trace RT on the PC. So there you had, okay, boom. It was just only went one hop. But let's go back over to, stop this share screen. Router 1, building 1. And now, from router 1, building 1, let's do a trace route. You can do this from your home PC. And if I brought up a command prompt, I could trace route to whoever we want to go to, the 200.1.1.2. There we go. So it first went to 172.16.60.3, then went to 200.1.1.1. 2 hops. There you go, 2 routers.
Okay.
Okay.
Yeah, that's what I'm looking for.
Yeah. So that would be your utility. And if you do a trace route to Microsoft, Microsoft.com, for example, now you can have some problems with trying to ping and trace route to some of these destinations because they don't want to be discovered for security purposes. So they have some rules about returning your trace route, but there's a lot of places that you would be able to trace route to. Probably best not to try and ping the CIA, for example, on a regular basis. They might wonder what you're up to. But all right, so that's routing sort of in a nutshell. But I mean, of course, there's a lot more that we can do to it, that we can affect the way packets go through our network, etc. But now that we have a full scenario, we have this scenario working, we can then go ahead and practice with this scenario for things like telnet, ping, and so forth, and trace route, as we just did. And that's the advantage of this. Now, what I'm going to do is I'm going to save this scenario as it's configured with OSPF. And then we'll be able to bring this up next week and use this scenario as we talk about other things. Even though we might not be talking about OSPF, at least we'll have the basic connectivity there. We can talk about switching and so forth, and all the other things that we would be doing. And that's what this scenario, as I said, is designed to do, is let you implement basically, 85 to 90% of what you would learn in a CCNA class as far as implementing security, switching, routing, connectivity, access control, first hop redundancy, et cetera, et cetera, et cetera. It's really has, serial and wide area connections, so forth. A lot of stuff. We even use NAT. In this scenario lets us use NAT and lets us learn about how NAT can be used in different environments and access control lists, et cetera. So we'll get to that actually. Well, let's see. Next Monday, I think, is a day off for the college. So we don't have class next Monday. So we would meet a week from tonight, and then we meet the following Tuesday, and then the next class starts the following Monday. Just to give you an idea of how it's laid out right now. Okay. If nobody has any questions, we actually could just wrap up right now. You guys can practice with this to the extent that you want. And we can come back next Thursday. And we won't, I think we've done enough with OSPF for now because of the type of course this is. And we'll be moving on to other things, a little bit on telnet, ping, trace route, and then on to switching and so forth.
I had a question. For
Yes.
the CCNA, like how many questions should I like really expect to be on the
On the exam,
exam? Yeah.
my recollection would be around between 65 and 75 questions.
Okay.
So Do you have an idea, a time frame when you're thinking about taking the CCNA?
Just probably when I'm done with this.
I'm sorry, what?
When this
Oh, okay.
semester ends.
Okay, so at the end of these 3 classes then. So what
Yeah.
I would suggest is, and I can start sending out some practice questions for you, but I would get a hold of a good bank of practice questions
Mhm.
and practice labs. And you know, the thing about practice questions that are good now, sometimes if you get certain banks, and it's changed over the years, believe me, this thing has gone all sorts of different ways, because what has happened, a little background in this, is that there were companies that would send people in to take exams, not for the purpose of trying to pass the test, but to get all the information from the exam, then come
Mhm.
out, put that information into practice exams, and then sell the practice exams. So they were trying to make money so that you could actually get sort of a pre-look at the questions. It wasn't legal. Cisco tries to discourage it, et cetera, et cetera. There is one website, 9tut, I think it is .com, I think 9tut, that was free, that had some pretty good stuff on it. But what I would do is begin to go out there and look at finding some bank of practice exams. And what I would try and get for practice purposes, that you're going to be between 400 to 600 practice questions that you want to see before you go in to take the exam. And what you want to be doing when you are ready to take that exam is you want to be passing that, whatever question bank that you happen to grab at any time, you want to pass that with, I think, a 90 to 95% pass rate for yourself. Now, the pass rate on the exam, I think, is 85%. I think you have to get 85% to pass the exam, but you want to be at 90 to 95% on your practice exams so that you have that extra margin. And part of it is that this whole thing is a profit center for Cisco and the other companies that do this.
Mhm.
And some of them are more straightforward than others. There was a time, and I haven't taken a certification exam in a while, so I can't really pass judgment on the state of things today. But there was a time when Microsoft, I felt, was extremely unfair. You would, take a class, like a $2,500 class at a training center called Server, let's say Microsoft Server. Then you go take the Microsoft Server test, and 25% of it would come from a Microsoft client class, which is really unfair.
What the heck?
Yeah. So there was a time when I would say legitimately, the way that Microsoft was playing the game, the only way you could win the game was to cheat, because Microsoft was cheating on their side. Therefore,
Yeah,
you know what I mean?
yeah,
Yeah.
good old Microsoft thing there.
Yeah. Well,
Things that
I
they
don't
always
know
do.
if I don't know if that's still the case. I really don't
Yeah.
know. Cisco has gone through various iterations. When I first took very first time I took the CCNA exam, and taken it many times, and of course passed it every time. But
Hmm.
the first time I took it, I felt that it was very straightforward. And
Okay.
so to me, what it did is it tested whether I knew the material, and I did, so I passed. As you went along, Cisco sometimes got a little tricky. And then you had to sort of get an idea, well, what are they trying to pull here? What are they trying to do to get me to, miss these questions? And on one hand, you want the exam to be tough,
Hmm.
because if it's tough and you pass it, then you have something to show somebody, and they will recognize that you've accomplished something because you passed it. There was something going on, and it probably still is to some degree, but you would be like, you'd get people would say, like, if you got your MCSE from Microsoft, that you were a paper MCSE because you passed all the questions, passed all the exams. But if you didn't know what you're doing, it doesn't do you any good. And the same thing is true in the CCNA. The fact that you passed the exam is a good thing, of course, for you to get out there and start your looking for a job. But if you pass the exam and you don't know anything, what'll soon show up at your job is that you don't know how to do anything. And then you won't be able to keep your job. So to me, what you really want to do is you really want to understand this stuff. So not only do you get to show the CCNA that you passed it and you should be interviewed and considered for the job, but that once you get the job, that you're competent. And that's one thing about this scenario that we just introduced tonight. When you get done and are able to fully configure this scenario, personally, I would think you could, print this out and hand it to somebody that might want to employ you and say, I can make and you'd have a list of all the things that you can make work in this scenario. And that in of itself, to me, would be a proof of your competence. And of course, you also want to have the CCNA, pass the CCNA and look at all that I can do and understand, et cetera, et cetera, et cetera. Again, that's just a personal opinion as to whether they would give that any credence, but this is a substantial scenario. When I first created this, I actually had 2 routers at each building. And when I showed it to the students the first time, they freaked out. And some of them quit the class, just like that. It was like, oh no, I'm not gonna be able to handle all that. Well, it's not that difficult. And out in the real world, you have to understand something at this level of complexity. So I guess my message and long-winded answer to your short question is, get a hold of practice exams and learn how to configure all these things to where you're very comfortable doing it. You can just do it boom, boom, boom like that. You can put this whole thing together, make it work, no time at all.
For sure. Yeah, I just remember like the commands is like doing it all like I forget certain steps.
Right. Well, that's just practice.
Yeah.
It really is. I don't do this for a year, come back to it. It's a little rusty at first. It's like, oh, okay, that's right. But and I had one time I was teaching early on. I taught for a couple years, and then I had like I think a 6-month lull when I didn't teach a class. And I was worried at that. Oh God, when if I go teach this class? Well, I've forgotten all this stuff. And I sat down to do a little troubleshooting. It's like boom, it was all boom, 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 came right back. So learn it really well, and then when you come back to it, if you do get off, away from certain areas for a while, it'll come back quickly when you have to refresh.
Right, for sure. Thank you.
Yeah, you're welcome. All right, well, folks, any other questions? Happy to answer them, or if not, we'll go ahead and wrap up for tonight. Okay.
I may have to miss Thursday's meeting.
Okay.
Uh,
So we don't meet Monday night, but we meet next Thursday, as far as I know. I will confirm that, but I know the college down here is closed Monday, and I'm pretty sure that Cabrillo has a holiday Monday as well. So, and what we can do, Roger, is I'll just send you the link to the recording.
Okay,
All right, you guys have a good weekend.
thank you.
Thank you.
Thank you, you too.
All right, take care.
Bye.
Bye-bye.
Bye-bye.